Hi everyone, in this video lecture we are going to learn about principles of amplitude modulation and review of signals and systems. Also time domain and frequency domain representations. Is Sri Devi, Professor of Electronics and Communication Engineering, Rogani College of Engineering and Technology. After completion of this session, the learners can easily able to understand the basic blocks of communication systems and basic concepts of amplitude modulation. Here is the block diagram of communication system. The basic elements are source, transmitter, channel, receiver and destination. So first one is the information source. It is followed by the transmitter, channel transmission medium with added noise, receiver, destination is the final block. Information source, transmitter, channel, destination from the receiver are the blocks one by one we are going to discuss in detail now. Initially, the first one is the information source. So, information source is the one which gives the information to the transmitter. The source and the destination are two physically separate points. When the signal travels in the communication channel, noise interferes with it. Because of this interference, the disturbed version of input signal is received at the receiver. So, the information source is the one which gives the information to the transmitter block. Next one is the transmitter block. The objective of the transmitter block is to collect the incoming signal and modify it to the suitable form which is needed for transmission and transmit the signal to the receiver through the channel. Channel is a physical medium which connects the transmitter block with the receiver block. The function of the transmitter block is to decide the type of nature of transmission of the signal. The information source generates the message signal to be transmitted. In case of analog communication, the information source is analog. And in case of digital communication, as we know, the information source produces the message signal which is not continuously varying with time. That is compulsory, it should be in the form of digital form rather than the message signal is message signal with respect to time and amplitude to in case of discrete form to be transmitted. So, even the message containing the text is also discrete. The analog signal can be transmitted to discrete signal by sampling and quantization. This all happens inside the transmitter. The next block followed by the transmitter is channel. See, the communication channel adds noise and interference to the signal being transmitted. So, this is the physical medium we said. Therefore, errors are introduced in the binary sequence received at the receiver. Hence, errors are also introduced in the symbols generated from the binary code words. This physical medium includes copper wire, coaxial cable, fiber optic cable, waveguide or free space etc. or different types of channels. To avoid errors, the channel coding should be done. The channel encoder adds some redundant binary bits to the input sequence. These redundant bits are added with the original information. So, this added redundant bit to the original information should be separated at the destination side. The block which is next to channel is called as receiver. So, in this receiver block, demodulation or detection should be performed inside this receiver block. So, here the demodulators are occurred whenever the modulating signal is discrete, then the digital modulation techniques are used. The receiver block receives the incoming modified version of the message signal from the channel and processes it to the next block. So, these are the great variety of receivers in the communication system. They are different types of receivers. So, they are depending upon the processing required to regenerate the original signal. So, So here the digital modulator maps input binary sequence zeros and ones to the analog waveforms. So every point of analog waveform should be converted to digital in the form of zeros and one. If one bit of time is transmitted, then digital modulator signal is represented as S1 of t and transmitted binary 0, and S2 of t is the transmitted signal which is for the binary bit 1. For example, we can consider S1 of t for transmission of 0 and S2 of t for the transmission of 1. So similarly we can convert the analog form signals to the digital form. Finally, at destination that receives the modulated signal. So at that destination point, the original signal should be separated from the modulated signal. So the function of the destination is to receiving the original message signal or information or modulating signal at the final point. So from this destination point we can get the original signal. So usually human will be the destination block. So this all are about the basics blocks of any types of communication system. Next is the by using this basic blocks, how this amplitude modulation, the concept of amplitude modulation is happening, are going to discuss here. So for here, while talking about amplitude modulation, we are going to tell about the need for modulation. So why modulation is required for designing antenna height, narrow banding, and to avoid poor radiation and penetration, and to determining the diffraction angle, and for multiplexing. So here the first diagram, there is one signal waveform and the with frequency fs, and second one here carrier waveform with higher frequency fc, and AM is the amplitude modulated waveform which is after modulation. So why the modulation is needed? So baseband signal cannot be travel for long distance. While it travels for long distance, its strength will be get weakened. So if you want to travel this baseband signal or low frequency signal to higher distance, we go for modulation, and modulation is needed for designing or to fixing the height of huge antennas. So it is not physically possible to design an antenna with higher height. So that with the help of modulation we can design the antenna with flexible or medium height for high frequency transmission. So it is also used for time division multiplexing or multiplexing concept, and for fixing refraction angle, etc. To learn about the basis of amplitude modulation, simply we are going to tell about two signals. One is called as message signal and another one is called as carrier signal. Both signals are there in the transmitter side. So this message signal or information signal is represented as Vm is equal to Vm sin 2 pi fmt. So here Fm is the frequency of information signal or message signal, otherwise it is called as modulating signal, and carrier signal, the next signal, carrier signal is Vc, that is equal to Vc sin 2 pi fct. So these two signals are combined and given as the input of the modulator, and after modulation we can get the modulated signal. So by using different types of modulators, modulation can be performed. That will be explained in the upcoming sections. So after modulation, the signal will have the modulation index m. So the modulation index m is represented as Vm by Vc. As we said earlier, Vm is the amplitude of modulating signal or message signal, Vc is the amplitude of the carrier signal, and this m modulation index can also be represented as Vmax minus Vminimum divided by Vmax plus Vminimum, where Vmax is the maximum amplitude of the modulating signal and Vminimum is the maximum amplitude of the signal we received at the output side, and always the modulation index is in between 0 and 1. If that value m is equal to 0, we can tell there is no modulation, and if m equal to 1, we can tell that is full modulation or critical modulation or 100% modulation. And if modulation index m is less than 1, that is called as distortion, that is the output is distorted signal. So always it is represented as Vmax minus V minimum divided by Vmax plus V minimum. So we said for m equal to 0 there is no modulation, for m equal to 1 that is critical or 100% modulation, and first diagram is for m equal to 0, we can tell this diagram represents there is no modulation. How we identified there is no modulation is here the carrier signal's amplitude is as it is, there is no change in the amplitude of the carrier signal, that's why we can tell there is no modulation. Coming to the next diagram, that is for m equal to 0.5, the amplitude of the carrier signal varies according to the amplitude of the message signal, so that we can tell the modulation happened here, and this is for m equal to 0.5 value, we got the output as like this diagram. And coming to the last diagram, for m equal to 1, the output of the modulated signal, that is the output of the modulator is like this. So here the carrier amplitude varies, so the carrier amplitude touches the reference axis. So here we can tell this for 100% modulation or critical modulation, here we have to note that m value is equal to 1. So here types of amplitude modulations are double sideband suppressed carrier modulation, single sideband suppressed carrier modulation, and vestigial sideband modulation. Double sideband suppressed carrier modulation, in short it is represented as DSBSC, and single sideband suppressed carrier modulation, that is represented as abbreviated as SSB, and for vestigial sideband modulation it is abbreviated as VSB. So to know or to learn about the equations of AM waveform, let us consider the equations of message signal and carrier signals. We already talked about the two signals we are using at the input side. They are message signal m of t and carrier signal c of t. These two signals can be represented in mathematical equations as m of t is equal to am cos omega t and c of t is equal to ac cos sin omega ct. So AM is the amplitude of message signal and AC is the amplitude of the carrier signal. Similarly, omega m is the frequency of the modulating signal and omega c is the frequency of the carrier signal. So these two signals are given as the input of the modulator, and the modulator inside the modulator modulation happens, and output of the modulator will be, these two are combined, and the final outputs will be here we are discussed that in mathematical form. So once modulation happened, the equation will be, or the modulated signal equation will be like that. So our message signal and carrier signal both combined, and output signal we are getting like this, that is AM of t, VAM of t or AM of t is the amplitude modulated signal. So AC is the amplitude after modulation. We can simply write that as AC is the amplitude of the carrier signal and AM is the amplitude of the message signal. Both are combined, and the output waveform consists three terms. One is message. Output waveform consists three important terms. One is the LSB term. LSB stands for lower sideband, and another one term is called as upper sideband term, and another one term is carrier term. So initially the amplitude modulated waveform consists carrier term, LSB term and USB term. Here the diagram shows the frequency spectrum of the carrier signal, LSB signal and USB signal. FC stands for frequency, carrier frequency, and FC plus FM stands for frequency of USB, and FC minus FM stands for frequency of LSB. And MA is the modulation index that varies from 0 to 1. So here this is a quiz question based upon the session we learnt. So initially we discussed about the basics or basic blocks of any type of communication system. So in that basic block, three important blocks should be considered. One is transmitter, another one is carrier, and the last one is receiver.